Thank you. Thank you for having here with us. I would like to welcome all the people who have shown interest in this webinar, and especially those who are joining us live. Today we are going to talk about digitalization in the paint and coatings industry, as well as in other related sectors. The topics of our webinars are always driven by you, I mean by our customers. In other words, we are here today talking about digitalization because we see a growing interest from your side. Let me introduce a little bit this webinar. I think that for decades, factories have invested in automating and their production and filling processes as much as possible. More recently, almost of our customers are looking not only to automate, but also to improve, make more efficient, and optimize all their processes. It's no longer enough for a process to be automatic. Nowadays, it must also be efficient. This efficiency helps reduce costs and consumption, increase production, and at the same time, guarantee quality in an increasingly competitive environment. The next step is to understand how to take advantage of digitalization to go further, because in other industries such as aerospace or pharmaceuticals are already adopting many of these technologies. Without a doubt, the paint and coatings industry will follow the same path. Some of the questions we can ask ourselves are, for instance, can we imagine autonomous processes? And I mean autonomous, not only automatic. Or how can already new technologies such machine vision and deep learning, collaborative robots, industrial IoT, additive manufacturing, nanomaterials, or for instance, digital twins could help us. And of course, the main question, how can we apply artificial intelligence in our sector? Unfortunately, today we are not going to answer all these questions, but we will open a window to understand which technologies are already reality, and together continue imagining what the factories of the future will look like. To do this, today we have three top-level speakers. We add their experience in the paint and coatings industry. Do you know how many years we get? Well, the answer is fantastic, because roughly, more or less, we have 100 years. Without a doubt, it's a huge amount of knowledge. I will introduce them as they speak. And at the end, of course, at the end of the three presentations, we will have a Q&A session. You can write down your questions in the chat at any time. There is no need to wait until the end. If you want, you can indicate which speaker your question is for, and I will pass it on. So we are going to start with the first speaker. Carlos, please join us. And let me a few seconds to introduce Carlos to the audience. So Carlos Bigas holds a degree in engineering and industrial engineering from Ramon Llull University, as well as a master in business administration from IADA Business School. He joined Oliver & Batlle 28 years ago, where he has held several positions of responsibility. He was head of the projects department, and nowadays he is currently the director of the pre-sales engineering department. He has extensive experience, a huge experience in the design and implementation of paint and coatings plants throughout his career. He has been involved in many international projects, bringing a very practical approach to designing and optimizing industrial facilities. Today, he will present TT Batch, one of our key solutions for recipe management. Carlos, thank you for sharing with us your experience, your knowledge. So go ahead, please, with your presentation.
Thank you, Carlos. Okay, hello, everybody. Today, I will be presenting the TT Batch, which is our software to manage automatic process, right? And next slide, please. When the processes I'm talking about are the ones related to the paint industry, which is our main sector as of now, in which liquid and solid dosing and transferring operations are involved, as well as the mixing process in dissolvers and finishing tanks to manufacture the final product, which normally is paint or related products, right? Next one, please. Okay, then to better understand the TT Batch, first of all, I should talk about the control system architecture, right? The architecture we can find in our plants is based on the following elements. So we can have a control room from which supervisor and monitoring, from which we can supervise and monitor the global process. We can also have a SCADA to supervise in real time and also to register the historicals and alarms. Next to the process equipment, we can find the HMIs to make local control process. From these elements, we can launch both semi-automatic or automatic operations. And we have also the PLC as an element who controls all the elements in the process, right? Then apart from all these elements, to manage a process, an automated process, we need the TT Batch, which is this piece that we can find in the right on the screen. Next, please. So the TT Batch is the software used to manage recipes automatically. With TT Batch, we can manage the stock of raw materials and also create recipes which can interact with the ERP of the plant. Next one, please. Right, then as far as the recipes is concerned, the TT Batch has a recipe repository from which we can select each formula as we can see in the screen, okay? Here they are the names of each formula with their ID number and the different characteristics which has every recipe. Next one, please. Then the formula or the recipes are created from scratch by using an intuitive menu composed by the different operations that can be included in a recipe. Such operations are in this part of the screen, the red ones, right? And then these different operations are drag and drop to the center of the screen and placed according to the sequence of the recipe. Each step is linked by using this kind of arrows corresponding that arrows that we need these arrows to fix the sequence in the formula, right? Next one, please. Okay, then when the recipe has been created, it can be selected from the repository that we have seen, and it can be automatically launched. When we launch a recipe, we can see, we can follow the status in real time by observing the different colors of each operation. So this formula starts at this point and finishes at this one. Then with blue color, in that case, for instance, we can see a step which is already finished. With green color, we can see ongoing step, and with the yellow color, we can see a step which is in standby. Meanwhile, all the green ones, the gray ones, are the pending the pending steps to reach the final of the recipe. Then the formula moves forward until the last step, and then next slide, please. Once fabricated, the recipe is saved in the recipe historical data, as you can see here. Here we can see all the formulas that we have already manufactured with each identification details, as the date of the creation, the hour, the time starting, the ending time, and the quantity, the amount of product produced, and details like this. Next one, please. As well, a detail of the different steps, as you can see here, can also be analyzed for the different raw materials involved in each recipe, right? In that case, we can see the different raw materials which have been involved in the recipe, in a particular recipe, and the quantities that we have that have been dosed for each product. Next one, please. No, not yet. Okay. Well, there will be two more slides. Well, one. In one slide, well, just to comment that we can see also time chart by showing the duration of each step, and also we can save process values if required. That depends of every customer. Like for instance, product temperature or electrical consumptions, right? Okay. Then, well, okay. The register of all the mentioned data makes TTBatch a reliable software, since it let us have a good traceability of all the operations and batch reports, along with the detailed records for each batch. Then, as benefits of TTBatch, we have an increased efficiency, obviously due to the automation of these processes, which implies also a cost reduction, right? And on the other hand, we can ensure that consistent quality is also achieved due to the repeatability of the automatic sequences that we run with this software. Next one, please. Okay, and then I would like to finish my presentation just telling you about the reasons to choose such a software like this for industrial automation, right? First of all, when I have to mention that our expertise after over 20 years doing automations like this, okay? And also mention that always we have a team of engineers who are supporting our customers when required, right? And finally, customization. Customization, this is probably the main advantage that we can do, that we can give with such a software. Why? Well, this is a software which has been created directly by us, so we have the ability to adapt it to the requirements of every customer, and this is for sure a very powerful advantage. Please keep it in mind. That's all from my side. Thank you very much for your attention.
So, Carlos, thank you very much for your presentation. See you later in the Q&A session, right? So, okay. See you later. Bye, Carlos. So, yes, now we are going to introduce our second speaker. So I call Mr. Josep Maria to join us. Josep Maria, if you could switch on the camera.
I did switch it on. Can you see me?
Yeah, okay, perfect now, fantastic. Thank you, Josep Maria. So Josep Maria Martínez holds a degree in industrial engineering from Polytechnic University of Catalonia. He joined Oliver and Batlle around 30 years ago with full-time dedication to expanding, improving, and implementing new technical challenges and goals in automation. He's currently the director of the automation and software department and specialist in automation of production and filling processes. He has solid experience in improving operational efficiency through automation solutions. Today, he will talk about the integrated management of end-of-line processes. So thank you, Josep Maria, to be here with us. It's your time.
Okay, hi everyone. Thanks for joining me. We're going to talk about the line management system. Okay, so let's have a closer look. The first thing that pops to my mind, could you just go to next? Thank you. The first thing that pops up to my mind is, what is the line management system? Is it a system? Yes, it is a system. It's an integrated system that monitors and optimizes the production line. Could you see down there that sentence? Those are the best and the most important words in my presentation. And I put an icon in a different slides that will flow through the rest of it for you to have a look. Manage, monitor, and optimize. So if you can see the pictures down there, there's a processes. Okay, the process is what each and every single station or machine that makes up the line, that is working cycle. When they work, all the information is communicated to people, and the people can have the metrics and performance and to have a look at it. At the same time, the system sends control as industrial feature, and that there's an impact in the commercial, for example, spare parts. Yeah, could you go to next slide, please? But what does the line management provide? Why? What is it? Okay, what things can give it to me? First thing, this is a data acquisition. So the real-time data is gleaned and get it from the production equipment. So it tells me the data, what facts are going on in the line. Second thing is that it gives me the status, how the line is working. Is it running? Is it idle? Is at fault? Another thing they can get from the line management is what events and alarms are going in the line. So in a way, I'd like to know what and how much it produces, what is going on, what is it stopping, what is not working. Let me know what's happening in the line while it's working. This is what the events and alarms and the status telling me. Fourth, the production tracking and reporting. This is the red tape. This is the reports to look into it. So those are magnifying glasses. Let me see what's going on in the line for me to track down what the glitches are and to work on them. And the last thing that provides me is the integration with maintenance and quality processes. Those two words are goal, and quality must always win, because quality is what we're looking for. So in a nutshell, that provides me data acquisition, line and status, events and alarms, production tracking, and maintenance and quality process. This is the icon up there. It tells you that it's telling me what it provides. Can you go to next slide, please? Next thing is, why do you need line management? Okay, you need line management to boost the production rate by improvement mainly. So if you find something is not working properly, then you know it, and then you have to fix it up, boost it up to rev it up. Let's go through the different 5 steps that I just included in the needs you may have. First, improving the line visibility and transparency. It tells you what's going on again. Faster response detection and deviations and failures. If it's not working, why it's not working? This is the bottleneck. This is what is not going on properly. Third, reduce downtime through proactive monitoring. Downtime is a nightmare because it's an impact in the optimization, and that affects money and costs, which is what it's about. Optimization means money, and that's what we are looking for. Get the best out of it. Standardize operational data across lines. So yes, what I get from that line, I can just put it in the other line. So that results tell me that I can use it to improve other things that have the same meaning, the same working, the same cycle. And also give me support from continuous improvement initiatives. Line management make me learn, make me understand, make me see what my weaknesses are, and let me improve my lines and my production. And this knowledge, I can just apply it to other different initiatives. Next step, please. Okay, how does it work? How does the line manager work? Okay, the line management is made up by machines, automated machines. Those machines have PLCs, automation, sensors, controllers. All those are the basement that makes the machine work. From those controllers, the line management get these data aggregation layers. So all the signals, all the data that the machines itself produce are aggregated, put in the middlewares, and send it back to LMS application, which can be the cloud or can be on-premise. This data also creates interfaces, creates reports, dashboards, and alerts. And those information, which is very important, they all sent to the MES, AirPass, or BIAS systems. So the flow goes from very low basic sensors and signals from PLCs to middlewares to LMS to reports, dashboards, and back to the system to the client have. An MES ERP system that have the tools to be able to understand and analyze. So in a way, the main goal is grabbing data to share it to your systems. You need it to manage. This is how the line management works. Okay, what do you get from the line management? There are 5 different measures that are important that you may have a look at. One is the overall equipment effectiveness. So measure how good is good enough. How good I'm working. Am I getting the best out of it to have to work better? This is the OEE tells me so. And also impacts on the availability, the performance and quality rates. So time is a big word. Time to know how fast, how well, how available the machine and the line is. Third one is the cycle time and throughput. This is measuring the capacity, the efficiency, how capable the machines are working properly. Fourth time, again, the nightmare. Downtime, cost, and duration. Stability, this is measuring how stable the line is. So keep it up, make it fluid and non-stop. The last one is scrappy defect rates. Again, this is the consequence of the downtime. So it responds on how is the quality doing. Those 5 measures are basic for you to have a look at and evaluate your production line. And that's what the line management does. Could you go to the next slide, please? Okay, where can I get the line management? Where can you see it? You can see the line management in every single production line that can be automized or semi-automized. So it doesn't mean it's painting, it's chocolate, is a fruit, is whatever that the line produces automatically, you can set up a line management. You can also see it in a multi-line manufacturing environments. Not only one line, but several lines that can connect one another and share data and shared processes. Okay, let's put a line management in the whole thing. Third one, in high volume or repetitive production processes. production processes. I mean, is a production line that products a product. It is simple, but it's complicated. Line management can give you a clue. 41 is operations requiring traceability and compliance. How well I've been doing the things. I've been doing correctly. I've been following the laws, the quality prospects, and the guidelines. Line management can tell you so. And the third, and the fifth and last one, but not least, the plans aiming for Industry 4.0. So that's the standardization and laws and compilation requirements that Industry 4.0 is sweeping, and it's also asking for some demands. Line manager can tell you, can give you the information that you can need for going to the Industry 4.0 standards. Can you go to the last one, please? Okay, wrapping up. What's the conclusions with all my presentation? First element provides structure and reliable operational data. So data for you to have a look, for you to analyze. Whatever that is, whatever that you need, LMS will provide it. Give you supports in real-time control and performance analysis. Real time, tell me what's going on now. And now I can react properly. Facilities, integration between shop floor and uptime systems. If you can see what the line management detects when the failures are, you can have spare parts to avoid downtimes. So the integration in your shop floor, it will integrate the data you need for have a good reaction. And the last one, foundation for optimization, automation, and data-driven operation strategies for improvement. Okay, line management is a tool you need to improve. It gives you a look, it gives you information, it gives you everything that you need and you don't know. Give it a go. Okay, thank you. This is the end of my presentation.
Thank you, Josep Maria. Nice and interesting presentation. As I said to Carla, see you later in the Q&A session.
Thank you.
Finally, we're going with our last but not least speaker, Arturo. Please join us here. You're here with us. Thank you. Let's move on to Arturo Laguna presentation. Arturo holds a degree in industrial automation and electronics engineering from Polytechnic University of Catalonia and master in business administration from EAE Business School. He has been working in a tech role for 28 years, where he is currently the director of the automation department. He has extensive experience in the development and implementation of software solutions for factory optimization. He specializes in digital tools that improve efficiency, allow production monitoring, and support decision-making in industrial environments. Today, Arturo will present applications that Tectrol is already implementing in other industrial sectors, and that we believe may also be interesting for the paint and coatings industry. So Arturo, thank you very much for being here with us. So it's your time.
Okay, so thank you, Carlos, and thank you to all the audience for your time and attention today. It's a pleasure to be here with you. In the next few minutes, I'm going to share with you 6 specific solutions we have developed for different industrial challenges. While each case is unique, they all share a common DNA, as they are strategic answers built on 3 main pillars. First, data exploitation. We take the raw data generated by manufacturing processes and transform it into valuable information. It's not the same having tons of data on a database versus having a dedicated dashboard with the information presented as you need. The second pillar is the role-specific visibility. So we present the data so it's actually useful for specific functions in the plant, from the operator to the manager. And finally, the process excellence. all these solutions focus on the improving the quality, standardizing the workflows, and optimizing the resources. It's important to note that these solutions has been successfully applied across various process industries, and as Carlos says, while some examples may come from other sectors, the logic applies perfectly to the world of chemicals and paints. And furthermore, you will see that many of these solutions can be integrated with the TT-Batch system, which has been previously presented by Carlos Bigas. So let's dive into our first solution, how we turn global production data into a simple color code validation dashboard. This is what we call a production validation portal, and is the first solution I'm going to present today. It was requested by a global company manufacturing similar products around the world, and they need a tool to minimize the effort for the final product quality validation. At the same time, standardize the criteria for this validation. What does it mean? They need a tool to avoid laborious and time-consuming laboratory product validation, and they found the solution on the repetitivity of the process. First, I need to say that by that time, they had a really good historical data across their factories, including recipe values with theoretical recipes and real values from production, process values as pressures, temperatures, flows, alarms, and even databases. And using those databases as input data, the solution applied was a real-time web dashboard that prepares this information in the background, and applying statistical and validation criteria show the production orders on a colored way. The tool, so the interface with the final user, was a dashboard showing the okay or not okay in a colored code of the different productions. If the production is green, the quality criteria are met and the production can be released to the packing lines. If the production is red, there has been quality deviations and additional actions are required. And obviously, the final user can navigate through the different reports and see the ones deviated. I think that this is a report tool, but it was much more than that. It basically turns raw industrial data into reliable quality dashboards. For the next case to present today is regarding manual operations. I include this solution in this presentation because it has been requested during the last year for many of our customers from different process industries, and it seems to be a common challenge in many plants, the manual operations. Many of our clients told us the same thing. How can we be sure that an operator doesn't make a mistake when doing manual operations? And we are talking about high-risk operation, like unloading a raw material truck into a tank or doing manual actions to a batch. The fear is always, first, the risk of a human error. So a wrong operation can ruin an entire production or a raw material tank. And second, the lack of traceability. Often, there is no digital record of exactly which batch was used or what time was it added. And this is a blind into quality control. So our solution was simple, and we apply to many sites this. Validation before action. We integrate barcode scanners directly with the plant control systems, the PLCs. And the rule is, if there is no correct scan, there is no action. For example, imagine that a truck arrives to the factory for unloading. Our system keeps the control element, the pump or the valve locked. And to start the process, the operator must scan two things. First, the barcode of the unloading spot, and then the barcode of the raw material, which includes a lot of information. The system validates this information against the database. If they match, the pump starts. If not, the system stays locked. Additionally, the software records the product, the time, the operator, and the supplier batch number automatically. And what's the result? We move from a process based on memory and paper to a digital foolproof system. For the next solution, let's see one of the trending topics of the moment, the integration of the AI to our industries. We call this artificial intelligence sensor or virtual sensor, or I don't know, soft sensor. Let me give you a bit of context and then go to the solution. As we automatize our plants, we often hit a physical wall, and there are critical quality parameters like color, viscosity, or pH that are very difficult to measure in real time. The physical sensors available on the market are often unreliable, expensive to maintain, or simply hard to install in the production lines. And this means we have data on pressures and temperatures, but we are blind regarding the actual chemical or physical state of the product until it reaches the laboratory. However, we are in the era of the artificial intelligence, and since we are collecting and historizing historical process data like flows, pressures, cooking times, we have a gold mine of information that we can use. The solution we apply here is a web platform also that allows the final user to create a model that, using your historical data, creates what we call this soft sensor. We don't install a new physical device. We use the intelligence of the data you already have from your process. The tool was designed to be used by the end user. So the end user was creating his own soft sensors. And this is done in four steps. The first one is the selection. You pick the data sources from your historical. Second is the correlation. The system automatically finds which variables actually affect the results. For example, how a temperature at the minute 10 impacts at the viscosity. Then the modeling, you select a built-in, already created by whatever mathematics, artificial intelligence algorithms to create a predictive model. And the last one is the validation. The system use data not previously used for the training of the model to validate it. If the result is not good, you can always go back, and this is just play with. In a few minutes, you have a new model. You can train it, and when you have something, when the model is ready, it goes live. From that moment on, the system can predict the process value of the future batches in real time without needing of a physical sensor. This tool changed everything. By using historical data, we allow the plant teams to see the quality of the product before the batch is even finished. We move from reactive, waiting for laboratory results, to being proactive and predictive. And we save money on complex hardware, and most important, we ensure every batch is perfect by using data intelligence. Let me put a slogan here. We are converting data into operational power. So if you can move to the next slide, please. The cross-department production portal. So let me also put a bit of context here. In many plants, we see a common frustration. Even though the machines are really automated, the communication between departments are still manual, based on phone calls and emails. So production, the laboratory, packing departments often operate as isolate islands. They use different tools, different data sets. They rely on Excel sheets, phone calls, emails to coordinate. This has several risks. Fragmented information. Each team only sees the part of the story. Delays. Everyone is waiting for someone else. Packing is waiting for the laboratory. The laboratory is waiting for production to finish a batch. And manual errors. relying on spreadsheets is slow, it's hard to audit, which is important, and it's dangerous when the plant grows. The solution, it was requested by one of our smart customers, and the solution it's a web-based orchestration platform that acts as a bridge that connects all those areas using a core system, the TT Batch as a backbone. The solution stands on 3 pillars. First, the real-time integration. The system automatically extracts process parameters and recipe details and historical values directly from TT Batch, so no manual entries. The second, the workflow orchestration between these 3 departments. Production see the real-time status of every batch. The laboratory gets an automatic notification at the moment the sample is ready for testing. And packing see exactly when the batch is released and ready to be packed without waiting for an email, and they can organize their resources accordingly. And also this is using a single source of truth. So we replace those messy Excel files with a unified dashboard, and every department has its own view, but everybody is looking at the same data. So we gain end-to-end visibility where every department knows exactly what's happening in the others. Go to the next one, please. I'm thinking I'm running a bit out of time, so I will explain the next one a bit faster because the concept is very easy. So in this case, what we found, situation was similar to other solution. The plant had a TT Batch integrated and a lot of historical data. And on the other hand, they had a third-party energy register, a system that saves energy consumptions to a separate database. The challenge here was how to cross the production data with the energy consumption data to assign each production line the energy consumption and report this back to the customer ERP. So we did that tool that was doing this, crossing all this information and reporting this back to the customer ERP. And finally, I'm going to talk about a functionality also integrated in TT Batch for one of our customers. And this is about what we call paperless projects. So even in high automated factories, we often find operators walking around with clipboards, filling paper checklists for quality inspections and maintenance tasks. And a specific production manager came to us with a clear problem. My operators already use TT Batch for everything else. Why are they still using paper for these verifications? The issue was not just the paper itself, it was the delay. If an operator wrote down a bad value on a piece of paper, the supervisor might not find out until the end of the shift. There was no real-time alert, no easy way to search through all the records, and of course, zero digital traceability. The solution we applied was a digital checklist. We moved to a web-based verification tool integrated directly as extension of the TT Batch. It is a flexible system designed for tablets that works in three steps. First of all, customization. The supervisor can create any type of a structured checklist or templates, from a simple yes, no, safe check to a complex measure values. The second is the guided execution. So the operator is guided through a digital sequence on their tablet, and they enter the data as they perform the tasks. And the third one is the smart validation, which I think is the important thing. The system does the thinking here. If a value entered is out of specs, the platform doesn't just record it. It immediately sends an automatic email alert to the manager, so a corrective action can happen instantly. If everything is within the limits, the report is secured, stored in our database and ready for further audits, but it's not disturbing anybody with emails or papers or things. With this final tool, we officially eliminate the clipboards from the factory floor. We standardize how manual tasks are performed, ensuring that every operators follow exactly the same sequence, and we have improved traceability to a level that, of course, paper cannot match, and most important, we have reduced the response time for quality incidents from hours to seconds. So just to summarize, we have covered different situations where digitalization and data utilization can make the life easier to all stakeholders and improve the quality of our processes. Thank you.
Thank you, Arturo. Thank you very much for your presentation. Please stay with us for the Q&A session. Now I'm calling Carlos and Josep Maria. Please join us again to answer questions. So let's move on the last part of our webinar of this Q&A session. So as I mentioned at the beginning of the webinar, you can send your questions through the chat. I will pass them on to the speakers. So I have different questions. I have also some questions for you. So I will address these questions. So for instance, we could start with Carlos. One question that we have here for you, Carlos, is from what plant size can TTBatch be implemented? And it's also asking if it's necessary to have an SCADA system to implement the TTBatch.
Okay. Well, then TTBatch is applicable to all plants that want to automate their batches processes, regardless of their size. One might think that in a large plant, it makes more sense to automate because more operations are carried out. But the small plants can also automate its processes if, for example, they are seeking greater efficiency and repeatability, as we mentioned in the presentation. No? Therefore, then implementing TTBatch is not so much tied to the size of the plant as to the way you want to work, really, right? Regarding the SCADA, the necessity of the SCADA, well, as for the need of the SCADA, if we recall the slide where we discussed the different pieces of the control architecture, we saw that the SCADA was one of the possible actors in this architecture, right? But it's not strictly necessary. That is to say that we can load recipes automatically without having an SCADA. Since the component within the control architecture that allows us to automate the process is not the SCADA, it's the TTBatch itself, supported only by the PLC, not by the SCADA. So there is no necessity of the SCADA at all.
Perfect, understood. Thank you for your response. So here we have, Arturo, for you a couple of questions. First is, you have presented 6 different tools, right? So do the solutions you presented require specific hardware?
Obviously, the one for the barcode scanners, it will require those readers and something to block the action, or at least signalize with I don't know, a green light or red light if the operator can continue or not. And for the others, those are software solutions. So the adequate IT, OT networks and resources like computer servers, HMIs, of course, will be required to make the performance of the solution work. And let me also say that if we want to apply all these solutions, cybersecurity is also key to be safe in all ways.
Perfect. Perfect. And here we have other question that I was waiting. So something about the future, to guess the future, and artificial intelligence. And the question is, how do you think artificial intelligence will help improve paint manufacturing processes? It's also for
so
you,
that's
Arturo.
$1 million question, right?
Yes, right, right.
If you see, almost all the solutions I have presented today have somehow relation to data utilization, and this is what the artificial intelligence is about, how to use all this data we have, big data, and how to transform it in intelligence, right? I don't know, maybe I can answer with an example that somebody gave me. We didn't do that from Tectrol, but one colleague of me was working on a big factory, and they had 3 boilers, and they want to optimize the boiler energy usage, but they need to know in advance when a new boiler needs to start, because it takes time to work at a set point. And the magic is that they fit an algorithm with the boiler gas consumption of the last year, and with this data, they got a predictive algorithm that let them know with time in advance when a new boiler needs to start. And this is the magic of the artificial intelligence. Those systems can find correlation and hide information in a way that for us is really difficult, right? So I don't know. At this point, I think that our creativity is the limit of what we can do.
Perfect. Thank you. Here we have one question to Josep Maria, and the question is, how does the LMS, the line management system that you have explained to us, transfer data from the production line to the customer's management system, such as MES or ERPs? You are mute, Josep Maria.
Okay, now can you hear me?
Yes,
Okay.
now perfect.
LMS by nature is bespoke. So bespoke means that is adapted to whatever system or way that the client can connect it and transfer from the LMS to the system. So being bespoke means is the body that's in the gown, not the gown in the body. So we don't have any corseted. So the answer is very simple. It's the client that tell us so, what data, how to connect it, which is implemented. Off the top of my head, I can say, for example, API applications like REST API, which I prefer to connect to the MES and allow the data transfer in common language, regardless of the software infrastructure. We can use middleware solutions like XML or JSON files, which is a solution. Database to database also is a way that we can transfer data. So the data is transferred by directly feeding information from the MES database to the LMS database. So that will be another method. We can also transfer data to MES by sending the production progress for the material consumption, quality data. All those things are defined by the client, because the client knows their system, their production, their product, and we integrated whatever it is into the LMS. So it does not really depend on the LMS. It depends on the client, depends on who's going to get the data and how it's going to get it somehow.
Okay, yeah. Thank you for your detailed answer. So here we have a question, Carlos. I think that's for you. Why choose TT-Batch instead of a general purpose recipe management system?
Okay. Well, here I could say that basically for 2 reasons. because of from one side, because of the customizable software features that TT Batch offers compared with the rigidity of the other market software. As I mentioned, TT Batch is built with an open code that we create ourselves. And as such, we have it open to adapt it to each of our clients' needs. As you know, different clients have different requirements, and therefore they need flexibility, flexible software, which is what we do with TT Batch. And on the second way, we can say that TT Batch is a software especially geared towards paint and related product manufacturing plants, for which it was developed. So using more generic and inflexible software will make it more difficult to the programmer to adapt it to the process in question. So that's the two things that I would say responding to that.
Perfect. So we have more questions, but unfortunately we are out of time. So as I said, there are still some questions left unanswered. But we will reply individually by email to those who whose questions were not answered. So thank you to Carlos, Josep Maria, and Arturo, our three speakers. It has been a very interesting presentation. Thank you to all. And thank you for attending this webinar. I hope you found it interesting, and I hope also to see you in the next webinars that we are going to offer to our customers. Thank you, everyone. See you in the next OOB webinars. Bye.
Thank you.
Bye-bye.